Who's hot, who not? Tell me.
Alright, so the first question you asked is, do I think math is an important skill to have? And why so, and why is it important? And, I mean, I very strongly think it's an important skill to have, not just because this is my field. I mean, there are a number of ways that it helps us to think better, think strategically. Probably more than any other field, it teaches us, or it's the place where we can learn to develop our logical processes, our ability to work through complex problems that require multiple steps and multiple stages. Teaches us how to organize in that way. There's a lot of overlap with a lot of our other classes. Matter of fact, the thing that comes close to me, or that resonates most with me from any other class, is probably the justification step taught in the Tolman writing method that's been taught since freshman year, right? Starting in speech and comp and going all the way up through. Right? That justification process is, as far as I'm concerned, logical proof. Right? It's geometry. It's that thought process. Whereas in geometry, you're focusing almost entirely on that. In other classes, the algebraic steps and all that thing is focusing on that in a very abstract kind of way. It's where that gets developed. So I consider it very important just from the thoughts. I'll talk more about that later when we get to the fifth question. Second question is, do you agree with the statement that Algebra 1 is the basis to any higher mathematics? And the answer is yes. The basic ability to develop mathematical thinking, abstract thinking, is the ability to think in propositions using variables and representations. Once you can abstract away from problems, it makes it easier to push through the logical steps and then come back to what those representations meant. It helps focus on how reason flows from one step to another without being distracted by the emotions and the other kinds of ties that we have to the ideas being talked about. It helps one to be objective, and it helps one's logic and thought process to be more solid and less shady, I believe is the right phrase. So, yeah, algebra is where it all starts, and it's also where a lot of science and technology is built from. When you think about, balancing chemical equations, that's balancing equations. Right? It's literally balancing algebraic equations. Right? But it's there. It's everything from programming computers, the language of computers, the language of science. And you can't have that stuff. I mean, you can't drop a car is basically a computer.
Oh, sorry.
On wheels now. So everything from mechanics all the way up through, developing high-tech airplanes and satellites and everything. So everywhere in there. Very important. The key to success, which is your third question, is practice. Right? I mean, the things we're developing, the ideas we're developing are natural. Right? These are our own mental abilities. We're developing our brains, the skills we've already got. And so what we have to do is practice them. The difference between folks who struggle in my class and the folks who are doing fine are the people who do their homework consistently. They're the people who study, not just the day before a test, but maybe start studying a little bit before that, practice their skills. Some folks come in with more talent than others or more background than others, and that's fine, but they will also eventually hit the wall where they no longer know what's happening, or there's something new to them, and then it's the same. They have to do the same thing as everybody else. They have to practice, they have to study, and they have to do problems until they get it. And then their brain develops. It's the same for everybody. The ones who struggle the most are coming with the least background, right? Because their mathematics education before they arrived here at KIPP wasn't as good as it ought to have been, or they didn't have whatever experiences or opportunities that we wish they had. And then again, the process will be the same, just that they have to start from farther back. They got to practice the earlier stuff that other folks have when they got here already. But it's the same process. They have to do the problems, they have to practice, they have to study, and they have to catch up that way. Your next question, what makes math different from any other core class? To a certain extent, I've touched on this already. It's a way of abstracting the reasoning process and developing sequential thinking, sequential logic, and reasoning. It is done better in mathematics and more frequently in mathematics than in any other class. It's used in all classes. You can't write a history paper without making an argument from evidence. You can't do a compare and contrast literature paper about different authors or about different characters and without logical connections between them. Right? So it happens everywhere, but in mathematics, it's all that's happening. I mean, that's all that it's about. And then the connections are built out from there. I mean, to a certain extent, that's what makes it different. And to another extent, it's because those skills are used in all classes. And to a certain extent, that's what makes math different, because those skills are essential in all classes at one point or another, sometimes extensively, depending on what kind of class it is. Your last question is, why do you think people say math is the future, and do I just agree or disagree? It's already here. I mean, I'm going to take this in two different directions. One is what the economy is built on. We have a high-tech economy built on electronics and moving into genetics and biology and chemicals, things of that sort. So, and a lot of that economy and the skills for that, they're all mathematics and science-based. So a lot of the economy is being developed there, which means if you want to be a part of the economy that's developing, you have to have some kind of background in these skills at different extents. You can be a super techie guy, or you can be just involved in that business, but you have to have some kind of understanding of what's going on. So because the economy is moving in that direction, it's become more and more important, in addition to the traditional ways that it's been useful for, like from how to run a business, the numbers of the business, and things like that. More importantly, the movements for social justice require mathematical thinking. When you use arguments, like when you gather evidence around what's happening in your community or what's happening in an economy or what's happening in the world, it's a kind of science and math. You want to see what's happening, in pollution in West Oakland, you have to do statistical analysis of the population, of the health impacts, whether who's sick and who's not, right? How much pollution is being emitted and what's not. Right? You got to get water samples and you got to analyze that, and that's all mathematics. You want to make arguments that are political. You want to convince folks. You need to give justifications. And again, here is where the mathematics and a bunch of other classes all come together. So a lot of the solid evidence and the building of arguments around social change, around social justice, is going to come with a kind of mathematical thinking behind it. Clearly, that's not all of it, but it's an important element. As far as I'm concerned, the most important part of mathematics is the part that advances
the same old pimp, mace, you know ain't nothing changed but my limp. Can't stop till I see my name on the blimp. Guarantee me and sales pull a level up. You don't believe in Harlem World, nigga, double up. We don't play around, it's a bet, lay it down. Niggas didn't know me 91, bet they know me now. I'm the young Harlem nigga with the Goldie sound. Can't no PD, niggas hold me down. Cooler, school me to the game, now I know my duty. Stay humble, stay low, blow like Hootie. True pimp, niggas spin no dough on